Yeah, beautiful people. What's up? How are you guys doing today? Um, so this is our third class on Asian application of Asian to solving to optimizing functions to saying if they are maximized or minimized and so on and so forth. All right. So we have a third example. Since this is the third video, and this should be the last video, except something else comes up, right? So here we have z equals 3x1, whatever this long function. Now let me say something. If this z here is not, it might be another letter, right? It's not always meant to be like it may not be z, all right? In another question, it might be y, right? So me writing zx1 x2 might be yx1 x2, stuff like that. So just take note of whatever your dependent variable is. So that's all. Right. Now let's start our partial derivatives. So you have zx equals zx1 equals, here we have 6x1 minus 5, yeah, minus x2. Here's x1 again, yeah. So minus 3x3, that's all. So zx2 equals this guy minus x1 followed by this guy plus 12 x2 minus 4 then plus 2x3. Yeah, it's 2x 2x3 2x3. Is the x3 again? No. So zx3 equals x3 is here. So we have 2 hmm, so we have 2x2 2x2 and x3 is there plus 8x3 plus 2 then minus 3x1. So optimizing the whole thing, you set them equal to 0. So when we do that, here we having 6x1, right, minus x2 minus 3x3 equals 5. Then here we'll be having minus x1 plus 12x2 plus 2x3 equals 4. And here we'll be having minus 3x1 plus 2x2 plus 8x3 equals minus 2. Alright, so we set up in a matrix form. Matrix A equals 6 minus 1 minus 3 minus 1. So 2 minus 3 and 2 8 x1 x2 x3, so equals to 5 4 4 and minus 2. Okay, so let me verify. 6 minus 1 minus 3 minus 1 12 and 2 minus 3 2 and 8. Okay, so looking for the determinant of A. Yeah, where is that other marker? So this is plus minus plus. Determinant of A is going to be 6 into brackets. This takes, so 12 times 8, 96. 96 minus 4, right? And it's going to be plus 1 into bracket. This takes away this. 6 times 8, 48 minus 3 times 2 minus 6. And let me be sure what I just did. Plus 1. Okay. Okay, this takes away this. So we are left with minus 1 minus. This guy takes away this guy. So I'm left with minus 1 times 8. Minus 1 times 8, which is minus 8. Then minus 3 times 2 minus 6. Okay. Then here minus 3 into brackets. This guy minus 1 times 2, that's minus 2 minus 3 times 12 minus 36. So determinant of A equals 6 into bracket 92 plus 1 into bracket minus 8 plus 6, that's minus 2, then minus 3 into bracket minus 2 minus minus 36, that's 34. Alright, so the determinant of A is going to be, where are you? 692, 1 minus 2 minus 3 and 34 equals 448. Alright, so same thing for we have A x1, right, equals to x1 equals to, so replace this guy by what is here, 5 4 minus 2 minus 1 12 2 minus 1 12 2, then minus 3 2 8, 3 2 8. So determinant of ax1 equals 4. You have plus minus plus, so you have 5 into bracket 12 times 8 96, 96 minus 4 92, 92, right, plus 1 into bracket this 4 times 8 32, 32 minus minus 4, that's 36, then minus 3 into brackets 4 times 2 8, 8 minus minus 24, that's 8 plus 24. What's the answer? 32. Thank you. Alright, so determinant of x1, let me verify. 592, 136 minus 3 and 32 equals 400. So x1 equals determinant of ax1 over determinant of a, which is 400 divided by 448. So approximately 0.89. Alright, so for x2, so we have ax2 equals, so we have to be careful, we go to the back to the original matrix, 6 minus 1 minus 3, 6 minus 1 minus 3. So instead of what we have in the middle here, we're having 5 4 minus 2, 5 4 minus 2, then minus 3 2 8, minus 3 2. So our determinant of ax2 equals 6 into brackets 4 times 8 32, 32 minus minus 4 36, right, then minus 5 into brackets minus 1 times 8 minus 8 minus 8 minus minus 6, that's minus 2, and this is minus 3 into bracket minus 1 times 2 is 2, 2 minus minus 12, that's 14. Okay, 6 into bracket 36 minus 5 into bracket minus 2 minus 3 into bracket 14, everything is 184. So x2 equals determinant of ax2 divided by determinant of a. So we have 184 divided by 448. Our answer is approximately 0.41. I'm kind of fast with these matrices because it's something that I'm not supposed to be doing all of this. I'm just meant to write the answers. X1 is 0.89, X is 0.41, and you should be left to figure out the whole thing. But let's still solve, right? But bear with me, I'm so fast. Alright, so we have ax3 equals, so the original matrix, 6 minus 1 minus 3, 6 minus 1 minus 3, then minus 1 12 and 2, minus 1 12 and 2, then 5, 4 minus 2 here. 5, 4 minus 2. So the determinant of AX3 equals 6 into brackets 12 times minus 2 minus 24 minus 24 minus 8 minus 32, right? Then plus 1 into bracket minus 1 times 2, that's 2, and 2 minus minus 12, 2 minus minus 12, that's 14, right? Then plus 5 into bracket minus 2 minus minus 36 minus 2 minus minus, what's the answer? 34. Okay, thank you. 34. So now let me cross check. 6 into bracket minus 32, 1 into bracket 14, 5 into bracket 34. So the answer here is minus 8. So x3 equals a x3 divided by a, which is 8, divided by 448. So your answer is approximately, wait, minus 8. Minus 8, so it's approximately minus 0.02. Minus 0.02. Alright, so those are our critical values. Now, are they minimum? Are they minimizing this function? Or they are maximizing it? So the first thing is our h. So our h is gonna be first number here, 6. And 6 is greater than 0, so that's positive. Now, what about our h2? H2, like I said in the other class, it's like you're just looking at 1, 2, 3, 4, taking the determinants of 1, 2, 3, 4. It's more or less as if you have something like this: 6 minus 1 and 12. And the determinant here is 6 times 12, 72 minus 1, which is 71. 71 is also greater than 0. That's positive. Then H3 equals determinant of A, like I mentioned in the other video, the previous one. H3 is determinant of A. I don't know why. For now, I don't know why it is so. No, I think I do. Sorry, I think I do. So for like I said in the other video, that H2 is you looking at determinants of 1, 2, 3, 4, see it was a 2 by 2 matrix. Then H3, which is the third principal minor, is you looking at the determinants of a 3 by 3 matrix. If there were H4, maybe it would have been determinant of a 4 by 4 matrix. So because the determinant of the O matrix, a 3 by 3 matrix, is the same thing as the determinant of A that we've gotten at the beginning. A, yeah. Right? So we don't have to resolve it again. So this is equal to 4, 4, 8. And here, this is as well greater than 0. So if you look at all of our Hessian, okay, H2 and H3, they are all positive, right? And they fulfill the conditions for minimum, for relative minimum, or for just minimum, okay, for minimization. So here, how do we conclude? All the principal minors are greater than 0. Let me cover this. All the principal minors are greater than 0. So that's telling us that they are positive. Hence, the Hessian H is a positive definite. Positive definite. And the function is minimized. And the function, that is this function, and the function is minimized. Okay. Here x1, x2, x3. Here x1, x2, x3 equal to 0.89, 0.89, 0.41 minus 0.02, 0.89, 0.41 and minus 0.02. And so that's it. I believe it is very clear. All right, it's clear enough. So the next thing is for us to give you an assignment, for me to give you an assignment. So if I were you, you know, if I were to solve questions that lead me into a 3 by 3 matrix, or let me even say 2 by 2 matrix, I think using the Hessian approach kind of makes it easier to show if the function is minimized or maximized. I just think, right? So if I were you, I may likely just apply this, whether the question asks me to use the bordered Asian constraint optimization approach or whatever approach. I just think this is kind of fast, and straightforward. I just have to apply my Cramer's rule, which is not that hard, and then just do all of these things for Asian. Okay, but whatever happens, just use the approach that suits you the best. All right, so don't say because I said so that that's what you are always going to be doing. No, just to if what is okay for you is to use the inverse method of matrices to solve your system of equations, then fine. All right. So our assignments. Yeah, some topics just have big names. They're not that difficult, as you've seen. So this assignment is here waiting for you. Glow by Debs has a monthly cost function. Glow by Debs is actually the brand of one of our students right now in 300 level. So anyway, Glow by Debs has a monthly cost function C equals 45x raised by 2 plus 90xy plus 90y squared. That's not a cost function really, but let's just enjoy ourselves. The company is going to make up, which is true. Assume the company only uses foundation brush, X, and makeup sponge. I don't even know what those things are, but it's okay. The price of which is it is or the price of which are the price of which are $2 and $3 respectively, with an order of 60 clients to be met this month. Remember that our cost function is a monthly cost function. So A, using Cramer's rule, find the optimum amount of foundation brush and makeup sponge for the company. All right. So that's for the month, right? That's for the month. Okay, then B is cost minimized using bordered Asian to test the second order condition. So just what we've done. So you find your H, you find your H2, you find your H3. So if they are all positive or if their signs are changing, all right. So that's all about that, and thank you very much. I think this is the end of our discussion on Asian, whatever, and so on and so forth. You might do something to be different in your respective schools, universities, and so on and so forth, but the rules are the same. All right, I've gone through a different section whose title is Bordered Asian Constraint Optimization, and the way it arrived at, or the way the conclusion was arrived at, if a function is minimized or maximized, is a little bit different from what you do when you are not constrained, right? But if you still apply your H2 and H3, you are still going to get the same conclusion at the end of the day. So I didn't say a big deal. It's more or less just duplicating the same thing. All right, so that's about that. See you in the next topic. I don't know what it is, but just see you in the next topic.